Hello, this video lesson is on point plotting, and I'm going to use the calculator to create a table of values. So if we look at the first example, by now you should have memorized the look of certain functions. So we'll start with this one. This one says f of x equals x cubed. And so it is a polynomial since it has a variable to a power. And so it's going to have smooth lines. All right, so this is your x coordinate and this is your y coordinate. And you know that's the ordered pair. So that's what we've got over here. And x is left and right. And that is always your first movement. And y is up and down. So we could plot points by putting numbers in. But we could also use the calculator. So I wanted to show you how to do that. So you hit table, and then it says number 1 f parentheses, and we just want to hit to edit function. Okay, and so I have a function in here already, so I'm going to hit clear, and then I'm going to put in this function, and the variable button is right here to the left of the 4. It says x, y, z, t, a, b, c, a, b, c, d. So you hit that, and you'll come up with x, and then you want to raise the function to the third power, and you hit enter. And then this screen comes up, and it's table set up, and you can start counting at 2, stepping at 1. That means the next number would be 3. Auto means it's going to fill the table in for you. In later lessons, you will want to use this x equals question mark where you tell the calculator what value of x you want. And x cubed, it has good negative values and positive values. So I'm going to start the table at like -3. So I'm going to hit enter, counting by 1. You can count by 0.5 if you'd like. Anything you want to count by. And then if you hit calc, it'll give you this table of values. So if I look over here, I'm not going to have room for -27. So I'm going to start at -2, -8, and then -1, -1, then 0, 0, then 1, 1, then 2, 8, and then 327 will be off my graph. So my ordered pairs are -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, and of course there's an infinite amount of ordered pairs. All right, now to graph, what we want to do is graph a y-axis, that's the vertical axis, and an x-axis, that's the horizontal axis, and we will count by ones. And you don't have to count by ones, you can count by each grid could be 2, and that would give you more points. But I'm just going to count, well, I want to go up to 8, and I don't have a very big graph at all, so I'm going to count by 2s. So if you count by something other than ones, you need to make sure you label your graph. So the -2, -4, up 2, up 4, up 6, up 8. So now when I graph -2, -8, I'll be down here. And then if I graph -1, -1, I'm going to go left 1, down 1. And if I graph 0, 0, I'm going to be right here at the origin. And if I graph 1, 1, I'm going to go over 1, up 1. And let's see, I messed up -1, -1, didn't I? -1, -1, there we go. And then 2, 8 would be over 2, up 8. Then I need to know the shape of this. A polynomial graph has smooth curves, no sharp edges. So you can see that it's going to keep going and get more and more negative, and then it's going to make a kind of a curve right here and then keep going up here. And you want arrows on the end, and you want the function to look like that. All right. Now the second one that we're going to look at, absolute value, you should know that that looks like a V. This is the absolute value function, and it looks like a V, and so we'll put values in. And One thing about absolute value, it's always positive. So that means all the negative numbers I put in are going to turn positive. So you don't really need a calculator for this one. So I want to put in a few negatives and a few positives. So if I put -3 in here, I get 3. If I put -2 in that absolute value, I get 2. If I put -1 in that absolute value, I get 1. And if I put 0, I get 0. If I put all these positives, I get the same number. So I get these ordered pairs. I draw my y-axis and my x-axis. I'm going to start down here a little bit because I know that I'm not going to have any negative y values. We've already said y, so that's x and that's y. So -3, up 3. -2, up 2. -1, that's left 1, up 1. 0, 0 is right here at the origin. 1, 1, over 1, up 1. 2, 2, over 2, up 2. 3, 3, over 3, up 3. And this is a function. There's the infinite amount of points, so you want to extend it past the points that you plotted and make sure you put arrows at the end so that you can let everybody know this function goes on forever and ever. All right, now this next one, there's a variable x at the bottom, and that's called the denominator, and we're going to be learning this later, but you might probably know that you're not allowed to have 0 in the bottom of a fraction, because if you do, you get, hit second clip, 1 divided by 0, you get a divide by 0 error, right? So I'm going to use the table to do this. Now, this is a very interesting one because not only do you want to put some negatives in, you want to put some small values in as well. So I'm going to count by half, and I'm going to start at -3. And so this is where the calculator can be helpful, because you're going to have some very interesting values here. So again, we're going to go to the table in an edit function, and we're going to clear that, and we're going to type in 1 divided by x. Okay, and then we're going to hit enter and go to the table. And so here I'm going to start at -3, so I will type in -3, and then I'm going to count by 0.5. Okay, and then I'm going to hit auto and calc, and you see these, you get some very interesting decimals, but I'm going to show you that you can turn those decimals into fractions. If you go over here and hit the squiggle, it'll turn it into a fraction, and that's really what we want on our graph. We don't want any rounding error in this class if we can help it. So -3, and then this is hard to see with my it's dark, but if you look down here, you can see that it's -1/3, and then -2.5, and that gives you -0.4. Hit the squiggle, gives you -2/5, and then -2 gives you -0.5. That's -0.5 or -0.5. If it's a terminating decimal, you can write the decimal, but see, this you would not want to write -0.67. That's a rounding error, so I'm going to hit the squiggle, and that's actually the fraction -2/3. All right, if I keep going, -1 gives me -1, and -1/2 gives me -2, and then 0, see that, gives me an error, so it does not exist. So what do we do with that? All right, I'm going to create more room here, just a few more positive values to the right of 0. Okay, so 0.5, 1/2 is +2, and then 1, 1, and then 1.5 That's positive 2/3. You need to hit the squiggle again. And then 2 is 1/2. And that's probably good enough. We're going to get the idea. All right, so what I want to tell you about is we have to know how to handle this does not exist. It's going to behave different ways on our graph depending on the situation. So let me get my x and y axis drawn. Y-axis, x-axis. And so you should know that if you have 1 over a variable, that's going to give you a rational function. And we're going to learn a whole lot more about rational functions. But for now, what I want you to know is that if you have a place where x can't equal something, it's going to probably show up as a vertical asymptote. It won't be a vertical asymptote if the factors in the numerator and the denominator cancel, but we haven't learned that yet. So for now, this is just a classic rational function. And so this spot right here is going to show up as a vertical asymptote. It's going to show up as the line x equals 0. Okay, so let me go ahead and graph these and then we'll come back to that. So -3, -1/3, go left 3 down 1/3 of the way. And that gives you -3, -1/3. -2.5 must be right here. And -2/5 is a little less than halfway down. All right. And then -2/5 is below that line there, below that -1/3 point. Okay, and then -2, -1/2 is, let's see if I can get this a little bit better. -2, -1/2 is right there, and then that's a little less than 1/2, and then that's about right there. Okay, and then -1.5, -2/3 would be a little bit lower. It's the reason I know what this is going to look like, and you will too right after this. So that's why I can kind of mess around with these points a little bit. -1 is right here. -1/2, -2, and then you get to 0. All right, and so that's this piece. Now watch what happens when you keep going. You have 1/2, 2, so go over 1/2 up 2, and over 1 up 1, and over 1.5 up 2/3, and over 2 to the right up 1/2. All right, and so you have to know what this rational function looks like because you actually don't connect these dots. Remember how we said x can't be 0? That's going to show up as a vertical line through x equals 0. So the y-axis is actually where x equals 0 is. Okay, so then what you want to do is you can't connect the dots, but you want to know that what happens is as x gets really, really close to 0 from the left, it's going to keep hugging this vertical asymptote. And as x gets really close to this y-axis, it's going to get closer and closer. As x gets larger in the negative, it's going to get closer and closer to 0. Okay, same thing here, because as x gets really close to 0, it's not going to ever touch 0. It's illegal to have x equals 0 in this function. And as x gets really large, it's going to go to y equals 0. Because if you put a large number in here like x, 1 over 1,000 is getting to be really close to 0. So it's hard to graph these if you kind of don't know what to expect. So that's why we had you memorize these shapes. But good news is that you can use the calculator to get your values. Same thing's going to happen with a square root function. So a square root function has an issue. You can't have a negative in an even index radical. You're going to learn about that, but let me just show you. If I try to find the square root of -4, I'm going to get a domain error. So I might as well not put any negatives in here. Okay, so I'm going to put 0, I'm going to put 1/2, I'm going to put 1, I'm going to put 2, I'm going to put 4, I'm going to put 9, and I'm going to put 16. Okay, so I'm putting a variety of things to show you how you handle it. So what we'll do is we'll go to the table again and go to number 2, edit function, and we're going to put the square root. Let's clear that out. The square root of x, and then hit enter. And we're going to start at 0, and we'll count by 0.5s again. And so you get 0 is 0, and you see when I put 1/2 in, I got a horrible value. See that value? And if I hit the squiggle, I'm not going to get a fraction this time. So we will have to round this to 0.71. But that leads me to the next point I wanted to make. You can pick whatever you want x to be. So it's a smart idea to pick perfect squares so that you get nice numbers. So if I pick 1, I get 1. If I pick 2, though, see how I get that? The square root of 2 is irrational, so we're going to have to round that. So after I do that, I figured it out. So I skipped 3, and I went right to 4 because I know the square root of 4 is 2. But again, you can use your calculator so you can keep scrolling till you see a nicer number. There's 9. The square root of 9 is 3. And then I'm going to have to go all the way to 16, all these irrational values. And then we get to 16, you get 4. Okay, so now we're ready to graph. These are all ordered pairs. And again, you don't have any negative x's and you don't have any negative y's, so I'm going to adjust this y-axis to be right here and the x-axis to be right here. So that gives me more coordinates to graph. Okay, so 0, 0, and then 1/2 up 0.71, about right there, and then right 1 up 1, and then 2, 1.41, there's over to the right 2, up 1, and then up almost a half, and then 4, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, and then 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, went off the graph, 1, 2, 3, that's okay. That gives us enough, and this goes on for a long time, forever, so we will have an arrow at the end, but we now know that this is what a radical function looks like, and you can use the calculator to get its table of values there. All right, so this is a radical function, and there's no need to put negatives. If you think through it just a little bit, you can't have any negatives in there. So let's say if you forgot, your table will tell you that. Okay, so it starts giving you errors when you get into negatives, so you don't worry about graphing those. All right, let's do one more. Let's do an exponential, and I'll do the fraction one. Okay, so quick rule with exponential functions are going to look like J's or backwards J's, and we're going to learn a whole lot about exponential functions, but for now, try to remember that if this value right here that's being taken to a power is less than 1 like this one is, it's going to be decay. It's going to look like that. You kind of have to know that. And then we're going to learn, but this x value, that's the exponent, and if the exponent is negative, it's actually going to flip this. So also there's no domain restriction on this, so I'm going to put negative numbers and positive numbers here. And so I'm going to start at -2. Well, see, I'm going to need more negatives. I know that. So let's say it's you and you don't know what's going on. So let's say you just start by putting it in the table. So edit function, clear that one out, and then you have 1/3 to the x power. So you raise that to this x to the square, and you put an x in. And I'll show you what will happen. So I'm not going to count by 0.5. I'm going to count by 1. So I'll start with, maybe you're not sure. Maybe you start at 0, and we'll count by 1. So I'm trying to be like what would happen with you. Okay, so if I hit calc, yeah, I've got values starting at 0, but see how small they are? They get smaller and smaller. But as you go into when x is negative, you see how much nicer they get? It gets big. So see, when this is less than 1, it's actually the negative x values that are going to give you graphable points. But there's really not that many good graphical points because it's a small grid. So I'm going to start at -2 and write those down. So there's actually, you know, a little bit of critical thinking even for graphing, even when you have a calculator to help you get the values. But this calculator is a good resource to kind of help you get a really good idea of why these things look the way they look, right? So if I'm I've got to go over to -2 and up to 9. So I need, I'm going to put this y-axis here. See, that's critical thinking too, kind of thinking about where your x and y axis would be best on this little grid here. Okay, so that's my y-axis and that's my x-axis, and I want to go to -2, 9. That's the order pair -2, 9. I think you get that idea, so I'm not going to write those in. So left 2, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -1, 3. 1, 2, 3, up. Left 1, up 3. And then 0, 1. That's called the y-intercept. And then 1, up a third. And then 2, up a ninth. And 3, 1/27. And 4, 181, and over 81, and you get the idea that this is going to get smaller and smaller. Y value is going to get smaller and smaller and smaller as x gets bigger. So as x goes to infinity, y is going to approach 0. Those little arrows mean approach. As y approaches infinity, y approaches 0. It means it's never technically going to touch it. There's your backwards J, but it's going to hug it. So there's actually a horizontal asymptote at y equals 0. So a horizontal line is y equals. And horizontal asymptotes have a different idea than vertical asymptotes. Vertical asymptotes mean you cannot touch it. But horizontal asymptotes, you could touch it when the values are small. But when x gets big, that's when it's going to approach it. So this is a classic exponential that is decay. Now this one is another exponential, and it's going to look like this because this b value here is greater than 1, so it's going to be growth. And so you could try that one. But I wanted to show you how to use the table to plot points.